Assalamualaikum warahmatullahi wabarakatuh. My name is Alvika Sari. I'm from Indonesia. I would like to present my research about the effect of ultrasonication time of the current synthesis of SO2 nanoparticle from oil palms. I'm a PhD student of Prof. Nazmi bin Hamzah and Prof. Hendran Samikan. And also the other authors, Associate Professor Anwar Iman Ramadan and also Professor Umar. I'm from Alvika MBU MPSA. And this presentation is present for the 8th Icmer 2025. This presentation will cover introduction, proposed statement, research objective, methodology, result and discussion, and also conclusion. This is the introduction. One of the most significant agriculture products in the worldwide is crude palm oil industry. The crude palm oil produced 78.25 million metric tons per year in 2024, and this industry produce liquid waste such as palm oil mills effluent, or we call it pomade, and it can be utilized into biogas and also in the solid waste such as empty fruit bunches, and it can be utilized into fertilizer, and also mesocrop fiber. It can be used as boiler fuel, and also oil palm shell or OPS. It can be used as boiler fuel, and the boiler ash contain high silica, more than 50%. So this is a potential raw material for synthesis of silica nanoparticle. So from the point of view synthesis of SO2 nanoparticles, there are several methods to produce the SO2 nanoparticles. The first method is ball mill method. This is a mechanical method. It is simple and scalable. However, the SO2 content is low and has a broader particle distribution. The second method is soldier method. It can perform the size less than 100 nanometer and also can produce high purity SO2 nanoparticles and also have a mesoporous structure and have a low energy requirement. However, the using the strong alkaline and also strong acid and using or required a long aging time with several washing to remove byproducts. So it's not environmentally meet. And the third one is the hydrothermal. Hydrothermal is also the mechanical method. It is a simple method. Have a chemical uniformity and a comparatively low process temperature. However, it took longer time, and the size is more than 100 nanometer. And the fourth one is ultrasonication. Ultrasonication can produce 27.69 nanometer improved particle dispersion and decrease accumulation, and also adjust nanoparticle size distribution. However, this method, the quantification method, is depending on the temperature, time, and also the frequency. So the problem statement of this research is we know that there are a potential source in the universe such as oil palm shells. This is very rich in silica content, but however it is a remote unutilized raw material, so it can be used as a potential sustainable resource for SO2 nanoparticle synthesis. For the synthesis method point of view, it can be synthesized from rich silica plant source. However, it's difficult to obtain high level of purity. So the conventional method for producing SO2 nanoparticle often involve a high energy consumption and harmful chemicals. This is all. It can be conflicting with the environmental sustainability goals. So we propose the ultrasonication method. This is a green synthesis offer a promising alternative of producing SO2 nanoparticle, offer better control over size and also purity. This is a eco-friendly process because it use less energy consumption and also less chemicals and less the water to produce. And however, the optimal ultrasonication condition, special duration, especially the time, is remaining poorly. So the objective of this study is to evaluate the effect of ultrasonication time horizon on the yield, nanoparticle size, FDR, and also some result and also purity. And the second one is to determine the optimal ultrasonication time in the synthesis of silica nanoparticle from OPS. So the main process is OPS, and we use the ultrasonication with a different time. but at the same in the constant temperature at 60 Celsius, and it produces SiO2 nanoparticles. And this is the methodology. And the study is carried out with the process of isolation and then purification, ultrasonication, calcination, and also characterization to obtain the data, FTER analysis, and also ADX analysis. And this is the constant condition of variable ultrasonic temperature 60, and then ultrasonication time 30 minutes, 60 minutes, 90 minutes on, and 120 minutes. So since the result and discussion, we can see from this picture the visualization of SO2 nanoparticle is black because this is the product is still high content carbon. Even the same ADX result, the carbon content is still high, and the yield, we use this equation. The yield demonstrates the efficiency of the process of synthesizing SO2 nanoparticles. We can see in here that the yield, the longer ultrasonication time can enhance the yield of nanoparticles obtained due to the effect of computation, which encourages the disintegration of particle agglomeration and improves the bonding between SO2 particles and solution. It can be seen from the table. The optimal yield is 8.156 yield. And this is the FTER analysis. We use the Achilles carry 630 FTER spectroscopy. The absorption shows the SO2 groups, and we can see in here the highest wave number is at 90 minutes. The SEM analysis using GSM IT300 scanning thermometing, you can see from this picture, the bright color, the particles are bigger due to the agglomeration and have irregular shapes. So it presents absorbance and reflect more electrons, which give them a brighter color. This is the size, the diameter size of the particles. We can see here the longer ultrasonication time has minimized the agglomeration process to the cavitation event. However, the longer ultrasonication time exceed than 90 minutes may lead to higher heat, resulting in bigger particles. The next is the same ADX analysis result. We can see from this table that the sample A, B, C, D shows the chemical composition of SO2 nanoparticles and the purity of components SO2 and also the oxygen. We can see in here that the most essential component is still carbon. Carbon is still remain high, and also the oxygen and also the silicon. This table shows that this product, nanosilica, is not pure, that the carbon remains higher. This is due to the higher isolation temperature. Because the higher than 750 Celsius, resulting in the higher carbon form. But we can see in the sample C, we can see that the on the 90 minutes, there are 35.74 for the 90 minutes. So in the conclusion, the cells on the ultrasonic time affect the yield, with the highest yield is 8.16% and small size. The result of the FTER spectrum indicates the presence of the ice bonds and also the presence of SiOH bonds. The evaluation of nanoparticle size through SEM analysis of the size variation at 90 minutes. Yeah, it's around 42 until 282 nanometers. The purity is the best at 90 minutes. And then in conclusion, the ultrasonic film time variation significantly impact the yield, size, and purity of nanoparticles. So my friends, thank you so much for your attention. Assalamualaikum warahmatullahi wabarakatuh.